Let's go to page 90 and let's do number 92. It says polynomial p of x contains only the only terms of the odd degrees. That means it's an odd function. When you have all the odd degree terms, so it's an odd function. When p of x is divided by x minus 3, the remainder is equal to 6. What is the remainder when p of x is divided by x squared minus 9? Okay, so first let's write out this. So when you have the polynomial divide, this will give you the quotient q of x plus r of x over x squared minus 9. Okay, and if you multiply, you get p of x equal to x squared minus 9 q of x plus r of x. Okay, and so what we're going to do is from here, so p of x when divided by, so you can remember the remainder theorem is the remainder and the substitution are interchangeable. Okay, so when you divide this and r equal to 6, what it means is that p of 3 equal to 6. So when you substitute 3 into the p of x, it will equal to 6. Again, remainder theorem. Okay. Now, if it's R function, okay, for R function, when R function is when you put p of the negative x will give you the negative value. So from here, because it's R function, so p of negative 3 will give you negative 6. Okay, so that's what the R function tried to tell you. Okay, so from here, what we're going to do is, so these are used for information. So from here, p of x, if you to factor that, and you want to factor so you can get the roots. So plus 3, x minus 3, q of x plus r of x. Okay, and because your divisor is second degree, so from here you can see that r of x would be 1 degree less than that, so it would be equal to ax plus b. Okay, because the divisor is the second degree, so the remainder would be the first degree. So this is always 1 degree less than that. Okay, so what we're going to do is we're going to start to evaluate. Okay, so p of 3 means you let x equal to 3. Okay, so the reason for that is because you want to make this equal to 0. So when x equal to 0, x equal to 3, this will become 0. So this part is gone. So it becomes 0 plus, and we're going to substitute this into ax plus b. Okay, so this is your ax plus b. So x equal to 3, so it would be a times 3 plus b. So p of 3 equal to 3a plus b. Okay, and from here we know that p of 3 is equal to 6. So we can set this equal to 6. Okay, and then we're going to do the p of negative 3. So p of negative 3, again, p of negative 3, when you substitute negative 3 in here, this will become 0. Okay, so again, that's the purpose of factor out, so you can apply the roots into here, so this becomes 0. So negative 3 into here, this becomes 0 plus, and it will be a times negative 3 plus b. So p of negative 3 will equal to negative 3a plus b. And this will equal to, from here, it's going to be equal to negative 6. Okay, because it's the R function. So when you substitute negative, you're going to get negative answer. Okay, so now we're going to put this equation down here. And we're going to add this together, so this will cancel out. So you got 2b equal to 0 divided by 2. So b equal to 0. So once you find b equal to 0, from here you can substitute into here. So you got 3. So you got 3a plus 0 equal to 6. Okay, this from here. So 3a equal to 6. So divide by 3, divide by 3. So a equal to 2. So once we find a and b, then we can find r of x, right? So r of x will equal to 2x, right? A is equal to 2, b equal to 0. Okay, so r of x equal to just 2x. Okay, let's go to number 94. Okay, so you have this polynomial is divided by the second polynomial exactly. So when you divide exactly means there's no remainder equal to 0. So you're looking for p plus q parentheses times r. Okay, so this one we can just go and do the long division straight. Okay, so you have x to the 4 plus 4x to the 3 plus 6p x squared plus 4qx plus r, and it's divided by x to the 3 plus 3x squared plus 9x plus 3. Okay, so that's going to divide. So first one would be x, so this would be x to the 4 plus 3x to the 3 plus 9x to the 2 plus 3x. Okay, then you go and subtract, put parentheses, subtract, so they cancel out. This will give you x to the 3, and this one will be subtract, so it will be plus 6p minus 9 x squared plus, this would be 4q minus 3 x plus r. Okay. Okay, now the next number, you can see that this is x cubed, this is x cubed, so that means you have to have a plus 1. Okay. So you're going to get x to the 3 plus 3x squared plus 9x plus 3. Okay? And again, remember the remainder is equal to 0, right? Because it divides exactly, so that means remainder equal to 0. Okay, so from here you can just do the matching. Okay, since this subtract this will equal to 0, so you can see from here you get 6p minus 9 equal to 3. Okay, for this one you get 4q minus 3 equal to 9. From here you can see r equal to 3. Okay. Okay, so from here this one we can solve. We can plus 3. So you got 4q equal to 12. Divide by 4, so q equal to 3. So we got r, we have q. Now to find p, plus 9 on both sides. So you got 6p equal to 12 divided by 6. So p equal to 2. So once we find p, q, r, now we can find our answer. We are looking for p plus q times r. Okay. So this will equal to 2 plus 3 times 3. So this will equal to 15. Okay. Let's go to the next one. Okay, number 95. So you have the three which you have r, s, and t are the roots of x cubed minus 6x squared plus 5x minus 7 equal to 0. So you're looking for 1 over r squared plus 1 over s squared plus 1 over t squared. Okay. Okay. So notice that this is a reciprocal. Okay, and so these are the square roots, the square of the roots of the reciprocal. So that means you're looking for the S2 from Newton's sum for the reciprocal. So first let's go and find the reciprocal. Okay. So for reciprocal you just reverse that. So you're going to get negative 7x cubed. So this number goes over here. Next one would be plus 5x squared. Okay, so again, so there's a reciprocal. Reciprocal, you just reverse the coefficient, and then you're going to get minus 6x plus 1 equal to 0. Okay, again for the reciprocal, so the equation with the reciprocal roots you just reverse the coefficient. So -7, 5, -6, 1. Okay. Then once you do this, then you can go and write the Newton's sum equation. Okay. So the S1, so S1 is equal to R plus S plus T. That's what it means. S2 would be R squared plus S squared plus T squared. Okay. Now since we already reversed, so once we find the S2, okay. Now don't get confused between this S and this S. Okay, they're not the same. Okay. So the S2. So first you need to write the S1. So S1, you're going to have the -7 S1. So S1 is the one with the first coefficient, okay? Plus the next coefficient, so it would be 1. See this over here, the subscript 1. So this will goes over here times the last number, times by 5, and this will equal to 0. So that's your S1 equation. The S2 equation would be -7 S2 plus 5. Again, just go down in order. Okay, so the first term we have this coefficient, the next term we have this coefficient. Okay, so it'd be S2, so -7 S2 plus 5 times S1. Okay, now the next one, so that's normal S after that, so it'd be, so you see the S2, the subscript, so it'd be 2 times the next coefficient, -6, equal to 0. Okay, so again, you just go down in order. But the last one, the last term, you have to times it by this coefficient over here. Okay. Now you don't need this one, but in case if you need the S3, okay, your S3 would be -7 S3 plus 5 S2 minus 6 S1 plus, see the 3, so it would be 3 times 1, okay, equal to 0. So that's how you write the sum, the Newton's sum equation. Okay, so you can coefficient that you just go down -7, 5, -6, 1. But the last one, whatever the last term is, you have to multiply by this coefficient over here. Okay, so from here you can solve. So -5 on both sides. So -7 S1 equal to -5. So S1 equal to 5/7. Okay. Now we can substitute into here. So -7 S2 plus 5 times 5/7 minus 12 equal to 0. So -7 S2 plus 25/7 minus 84 equal to 0. So -7 S2 minus 59/7 equal to 0. Okay, so move this over. So -7 S2 equal to 59/7. Then from here, go ahead and multiply by -1/7. Multiply by -1/7. So this will cancel out. So S2 equal to -59/49. Okay, let's go to the next one. Okay, number 97. Okay, so you got Q1 of X and R1 are the quotient remainder respective when X to the A is divided by X plus 1/2. Okay, and if Q2, so Q1 of X divided by X plus 1/2, you get